Okay, good morning, good afternoon, or good evening, everybody. Today is our final lesson of the year with box plots. Very exciting. So box plots are similar to dot plots in that these are just another way of representing our data visually. So the box plot displays our data using 5 special features. So we're going to go through their definitions and we'll look at the box plot below. So the first thing that we look at is the minimum, which is our smallest piece of data. That is going to occur all the way over here on the left. So I'm marking that in pink here. That is going to be our lowest value in our data set. We then move on to forming our box using the lower or first quartile, which we can also refer to as Q1. And that is our median of the lower half of our data set. So that piece would be the left-hand side of the box. We will get into, when we get into our first example, how do we calculate that median of the lower half of our data. The next value is the middle of the box, which is our median, and that is the middle data value when we have our data ordered from smallest to largest. So our median is visible in the box plot. We then have our upper or third quartile, which again can be referred to as Q3, as the right-hand side of our box here. And again, we'll get into our first example with how do we calculate that median of the upper half of our data. Now, if you're wondering to yourself, how did I just go from Q1 to Q3? That is because of the fact that the median can also be referred to as Q2. So we don't often refer to it as that, but I do want to just show you guys that's where it's coming from, that we go from Q1 to Q3. So Q1, median, and Q3 are lower, median, and upper quartile form the box in our box plot. And then we have all the way on the right our highest value with our maximum. Sometimes these are referred to as a box and whisker plot because of the fact that we have the box in the middle and we can kind of look to those side pieces as whiskers. As a crazy cat lady, you know I love that it could be referred to as a box and whisker plot. We can also, from this box plot, take our range, which is the highest minus the lowest value, because we can see that maximum and minimum. And then we can also calculate what's called the interquartile range, which is sometimes abbreviated as IQR, so the interquartile range. And this is the difference, which means subtraction, between the first and the third quartile. So for this, I would take quartile 3 minus quartile 1 to calculate our interquartile range. So one of the things with our quartiles, that prefix quart meaning 4, is that our data gets broken up into 4 pieces. And so we can kind of see that here, that we have like 1, 2, 3, 4 pieces of data that I kind of just squiggled in blue there on the box plot. And so what we're looking at here is each of those quartiles will represent about 25% of our data, because again, quarters, we can think of 4 quarters in a dollar, right? So it's going to be about 25% of our data each. So the interquartile range is actually really nice, because that's actually going to give us the middle 50% of our data, right? Because it is 2 of those quartiles. So when we look at our data, again, this is a nice visual blocking that we can see where that middle 50% will fall. We can also see how our data is spread out. So a big difference between the dot plot and the box plot is that the dot plot that we learned about in the last lesson really is good for frequency of how often something occurs, but the box plot is really a good way to look at that middle 50% of our data and how spread out our data is. So let's go into how do we actually make box plots. So for our first example here, the following data set represents the number of animal crackers in a snack-sized box. The first thing that I want to do, especially since I'm going to be going for the minimum, median, and maximum, is I want to order my data from least to greatest. So I'm going to go through my data set and I'm going to look for the smallest value. This is something we want to be really careful with as we go through. So my smallest number in this case is actually the first one. That was nice of them, of 34. I'm going to cancel it out so I know that I've already used it. My next smallest number is 45. We then have 47. There's 2 48s. and I'm going to run out of space here, 49 and 50, right? That is very sloppy, so I'm actually going to rewrite that over here so I have a little bit of space to fill things out. So we have 34, 45, 47, 48 happening twice, 49 and 50. Somehow my big handwriting is still getting me here. All right, so our minimum value in this, I'm going to look all the way to the left because we've ordered it from smallest to largest, is 34. Our maximum value is 50, right? So all the way on the left is our minimum, all the way on the right is the maximum. Now to get our median, we're going to go all the way into the middle. So last time I had you guys canceling out left and right, left and right, left and right to get all the way into the middle of a median of 48. Now, I do want to actually be able to see that data set. So I'm going to back off of this. That was 48 in the middle, because I then want to be able to calculate our first and third quartile. So for these ones, I have to look at the lower half of my data set, which is all the data below the median. And I want to look for the median of that lower half of my data set. So the middle number in 34, 45, and 47. We're very fortunate here in that since there's only 3, the middle one should be pretty obvious to us that we're going to get 45 as our first quartile. All right, we're then going to look at the upper half of our data set, so what's above the median. And again, for our third quartile, we're going to go for the median or middle number here. So what's the middle number in 48, 49, and 50? The middle number is 49. Oop, I just realized we did not have a 0 there. Okay, so now how do we calculate our box plot? So what I'm going to do is I'm going to plot all 5 of these numbers using a dot. So I'm going to plot a point at 34, so it's just a little bit below 35. Plot a point at 45. Plot a point at 48, and I'm approximating here, 49 and 50. What I'm then going to do is I'm going to form the box using the middle 3 numbers. So I make the box and I mark my median. We can then form the whiskers by extending out to the lowest and highest number. Okay, so again, I plot those 5 points, and then I make the box around the middle 3 and extend my whiskers to the lowest and highest. Okay, for our next set of numbers, I'm already anticipating that this will be a problem for my big handwriting, so I'm going to give myself some space up at the top here. So the following data set represents the number of hours a small candle will burn. Again, I want to go through this list, and I want to go for smallest to largest. So I'm going to go through and look for my smallest number here, which is 7. All right, so this question, again, I'm going up on the top here. And then my next smallest number is 8. We then have 9 happening twice, so I'm going to list that out twice. We then have 10. There are 2 11s. We have 12. And no 13, but there is a 14. There are 2 15s. I have a 16, and then our final number is 19. Okay, so going through our data set here, we can look all the way to the left since we're in order for the minimum of 7. We can look all the way to the right for the maximum of 19. The median, we're going to go into the middle here. So I'm going to cancel out left, right, left, right, left, right, left, right, left, right, left, right, and we have a median of 11. Since I'm going to need to go through my data set again, I'm going to undo that canceling. This was our median here. All right, so now to find my lower quartile, I'm going to look at the lower half of my data here. And so I need to cancel out, again, left and right, and then average out those 2 middle numbers. So 9 plus 9 giving us 18, divided by 2 gives us an average of 9. We then look at the upper quartile, so I'm going to highlight what's above the median. I'm going to work my way into the middle here. So I want the median of that upper half. So I'm going to cancel out left, right, left, right. I have two numbers in the middle. So again, we average 15 plus 15, giving us 30, divided by 2, giving us a Q3 of 15. Okay, so now to make our box plot here, I'm going to plot those 5 points. So I'm going to plot 7. Again, I can just kind of approximate where that's going to be. I'm going to plot 9. I'm going to plot 11, 15, and 19. We're going to make the box around the middle 3 numbers. So I form the box here, and then around the median. And then I extend my whiskers to the lower and the lowest number and our highest number. So not only should we be comfortable creating box plots, but we should also be able to read them knowing that they're going to tell us the minimum, Q1, median, Q3, and the maximum. So for this box plot, we want to determine the 5-number summary. That's our minimum, Q1, median, Q3, and maximum. So our minimum is going to be all the way to the left here. So our minimum is 11. Our Q1 is the left side of that box. And so I'm going to look here. This is about 12. Our median is the middle of the box, which is 14. Our Q3 is the right side of the box, which is a little bit below 17, so that's 16. And then our maximum is the rightmost point, and so that is a little bit above 17. That's going to be 18. All right, so now we want to try this. So Amanda surveyed 13 students in her class about their height in inches. Her data are listed below. We want to know which box plot correctly displays her data. So there are 2 things that I can find very quickly from this data set because it is very nicely put in order for us from smallest to largest. So I can find the minimum and I can find the maximum very quickly. So the minimum is 52, so I know that the lower side of my whisker has to be at 52. So I know this one's okay. This one actually has a minimum of 53, so that's out. Same with choice C, that's out. And then choice D has a minimum of 52. So I'm now between choices A and D. So then I look at the maximum. These both have maximums of 65. That does not help me eliminate anything. So I can then look to my next easiest point to find, which would be my median. So I'm going to cancel things out to work my way into the center, again, canceling out both left and right sides, and I end up with a median of 58. So I look, choice D has a median of, looks like 58.5 because it's right between 58 and 59, so that's going to be out. Choice A has that median at 58, so that one looks good. We actually did not need to worry about finding our quartiles here, so that was really nice. All right, number 2. A principal gathered data about the distance in miles that his teachers and bus drivers live from the school. The box plot below shows these data. So this one is really interesting because this box plot has 2 different pieces of data. It has the bus driver data, and then it has the teacher data. So we actually see that there are 2 box plots representing 2 sets of data. And the question asks us, based on the box plots, which statement is true? So let's see if we can go through and maybe eliminate some answers. So the first one's talking about the interquartile range. And so we remember that the interquartile range can be calculated by doing Q3 minus Q1. So the bus driver interquartile range, I can do the Q3, which is this point right here, which is 20, minus Q1, which is this point right here, giving us 10. So the bus driver interquartile range is 10. Now, for the teacher interquartile range, I am going to calculate, again, the Q3, which is 30, minus Q1, which is 15, giving us an interquartile range of 15. So choice A says that the interquartile range of the distances for the bus driver, which is 10, is twice the interquartile range of the distances for the teacher. Well, 10 is not double 15, so that is out. Choice B says that the range of distances for the teachers is twice the range of the distances for the bus drivers. Now, this one we're going to be very careful with because we're talking about range, not interquartile range. So I have to look at, for the range, I want the maximum minus the minimum. So my maximum for the bus driver is 30, and the minimum for the bus driver is 5, so our range here is 25. For the teachers, again, we want the maximum minus the minimum. So our range here is going to be 35 minus 5, giving us a range of 30. All right, so let's go back to the question. The range of the distances for the teachers, which is 30, is twice the range for the bus drivers, which is 25. Well, 30 is not twice 25, so that's also out. Okay, choice C, the interquartile range of the distances for the bus drivers, so we go back, the interquartile range here was 10, is 5 miles less than the interquartile range for the teachers, which was 15. Okay, so is 10 5 miles less than 15? Sure is. So this looks like it's probably my answer, but I'm going to make sure by just eliminating choice D as well. The range of the distances for the teachers is 5 miles less than the range of the distances for the bus drivers. So it's asking for teachers' range, which was 30. Is that 5 miles less than 25? No. This one we have to be very careful with because if they switched it, it would have been true. But since it's saying teachers is 5 miles less than the drivers, that's out. All right, well, one more question for us here. A bowling team participates in a 2-day tournament and records the scores for each team member on both days. The scores for both days are represented by the box plots below. So again, I have 2 separate box plots here. I have Friday's box plot and I have Saturday's box plot. Now, one of the things that I want to look at very carefully here is that it doesn't give me all the numbers, so I might want to fill those in. So I look at how do I get from from 200 to 225. That's going to be in increments of 5. So this is 205. This would be 210, 215, and 220. Working backwards, this is going to be 195, 190, and this is 185 and 180. Good, so now I have all those numbers that I can pull from. So which conclusion can be drawn from the box plot? So here, all of my answers are talking about either the median or the interquartile range, right? So median, interquartile range, and median, interquartile range. So I need to find those 2 things. So let's look here. For Friday, we have an median, which is easy to find. That's our our middle line here. Our median is 215. And then for Saturday, our median is 205. All right, then I'm also going to calculate my interquartile range for Friday, which is going to be this 210 minus 220 here, minus 200. So my interquartile range of 220 minus 200, giving us 20. Okay, then for Saturday, our interquartile range is going to be 210 minus 190. So 210 minus 190, another interquartile range of 20. So they have the same interquartile range, but different medians. So let's go through our answer choices. So choice A says that the scores on Friday and the scores on Saturday have the same median and interquartile range. Well, they do have the same interquartile range, but they do not have the same median, so that's out. Choice B, the scores on Friday have a greater median and a greater interquartile range than the scores on Saturday. Once again, same interquartile range, different means. And they are medians, and they are not greater both times, so that's out. Choice C, the scores on Friday have a greater interquartile range. Well, all right, I know that they have the same interquartile range, so again, out. D, the scores on Friday have a greater median, which they went from 215 down to 205. So yeah, they were bigger on Friday, but both data sets have the same interquartile range. So looks like choice D is our correct answer. Thanks for watching. I can't believe that our year is done already. I miss all of you guys and looking forward to seeing you next year. Bye-bye.